July, August, and September 1967. These months brought this nation to the eve of a climactic point in its manned spaceflight program. For about to be inaugurated was the final phase in the development of a manned spaceflight capability so far-reaching, we can soon land men on the moon. An event first magnitude in importance will be the unmanned maiden flight in the development of Apollo Saturn V, the space vehicle which will ultimately carry American astronauts to the moon. The maiden flight, an Earth orbital mission, will culminate years of design, development, manufacturing, testing, the efforts of hundreds of thousands of people. Major objectives are to prove out the space vehicle systems and structures in flight, and to verify the spacecraft heat shielding for lunar mission re-entry velocities. The complete Apollo Saturn V stands some 363 feet high and weighs more than 3,000 tons. The 5-engine first stage, built by the Boeing company, delivers 7.5 million pounds of thrust. The flight will be its first. The 5-engine second stage, built by North American Rockwell, delivers more than 1 million pounds of thrust. The flight will also be its first. The single-engine third stage, built by McDonnell Douglas, delivers more than 200,000 pounds of thrust. The stage has flown in uprated Saturn I missions, but now for the first time it will be shut down, then reignited in space, as must be done in the lunar mission. The instrument unit, which contains guidance and control equipment, has also flown previously, but never with requirements so demanding. A test model of the spacecraft module for manned lunar landings will be flown, providing proper structural loading. The spacecraft service module, which contains a propulsion system and other equipment, has been flown in 2 previous missions, but will now be subjected to its longest continuous burn in space. The spacecraft command module, which carries the 3-man flight crew, has also flown previously and been qualified for re-entry from Earth orbit, but it has never re-entered the atmosphere at lunar mission velocities. The effort to prepare the Apollo Saturn V space vehicle for launch has been paralleled by the effort to prepare a massive complex of new mission support ground facilities. The launch complex itself is new. The Launch Control Center is new. There are new instrumentation facilities. New mission control equipment. New computer facilities. New communications and tracking facilities. Expanded launch vehicle monitoring facilities. Mission plans call for the flight to last approximately 8 3/4 hours. Highlights will include first and second stage burns during launch, a coast period in circular orbit, reignition of the third stage, an apogee of more than 11,000 miles, and a re-entry at 25,000 miles per hour, the velocity anticipated for the lunar mission re-entry. On August 26th, at the Kennedy Space Center, Complex 39, Florida, the first Apollo Saturn V was transported from the Vehicle Assembly Building to Launch Pad A, a major transition in pre-flight preparations. For preceding this event were months of extensive work in Kennedy Space Center facilities, the work necessary to assure the individual flight readiness of the launch vehicle and spacecraft, the work necessary to mate the Apollo Saturn V, the work necessary to check it out, It was only after a series of electrical and mechanical tests, simulated countdown tests, simulated flight tests, that the Apollo Saturn V space vehicle was declared ready for transport to the pad and final checkout for launch. With the space vehicle on the pad, the Apollo ground support facilities were to be unified into a vast operational complex for the first time. Many tests were being conducted to assure that the facilities were compatible with each other as well as with the space vehicle. For example, launch tower umbilical arms, which carry electrical and propellant lines to the vehicle, were subjected to a series of operational tests under simulated launch conditions. The objective was to assure that the arms disconnected cleanly and swung back properly. At the end of September, checkouts for the first Apollo Saturn V were continuing on Pad A. Simultaneously, the second Apollo Saturn V was being mated and tested in the vehicle assembly building. The second mission will be largely a duplicate of the first, the objective being to increase our confidence in Apollo Saturn V, that it may be declared ready for man. Less spectacular but equally important to the program is our present status on the Saturn V's second stage, for months a source of development problems. 3 ground test stages had been lost. Defective welds were uncovered. Surface imperfections were discovered in stage walls. Tank insulation had failed during fuel loading and pressurization. To surmount these and other similar problems, NASA's Marshall Space Flight Center and North American Rockwell instituted new manufacturing, assembly, and handling techniques. They tightened quality control, revised management procedures. As a result, quality and stage performance improved markedly, and early requirements to static fire each second stage twice before acceptance have now been reduced to the normal single static firing. At the end of September 1967, the second stage for the third Saturn V had been static fired at the NASA Mississippi Test Facility and accepted for flight, and second stage schedules were again in line with Apollo program requirements. This firing also signaled activation of the final static test stand built at the site. While recovery from problems characterized progress for the Saturn V's second stage, continued steady advancement characterized progress for the first and third stages. On August 25th, a first stage underwent a 125-second acceptance firing at the Mississippi Test Facility. Scheduled for flight on the 5th Saturn V, the stage performance was completely successful. The following day, at McDonnell Douglas Sacramento Test Operations, California, a third stage underwent an acceptance firing lasting 438 seconds. Again, a completely successful performance. Meanwhile, the Kennedy Space Center continued preparations for the unmanned first flight of an operational lunar module to be launched by an uprated Saturn I. Checkouts of the lunar module were interrupted by plumbing leaks in both the descent and ascent propulsion systems, a problem which necessitated the removal and modification of fuel and oxidizer lines. At the end of September, the lines had again been installed in the lunar module and checkouts were underway. Major objectives for the mission will be to prove out the lunar module structures and propulsion systems in space. Preparations for the unmanned first flight were paralleled at the Manned Spacecraft Center by preparations for a series of lunar module ground tests. Following checkouts of hardware and procedures, the ground test lunar module, delivered by Grumman Aircraft in September, will be placed in an environmental chamber and eventually subjected to manned tests under simulated space conditions. This will be a major step in qualifying the module for manned missions. With qualification approaching, the second and third flight lunar modules were nearing completion of factory assembly and checkout at Grumman Aircraft. The second is presently scheduled for an unmanned mission, the third for a manned Apollo mission. At the end of September, preparations for the first manned Apollo mission were progressing, both at North American Rockwell and the Manned Spacecraft Center. Virtually all problems surrounding the tragic Apollo fire at Cape Kennedy in January 1967 had been resolved. The spacecraft command module is now equipped with a new quick-opening hatch, new covers and guards for panels, new fireproof containers for potentially flammable materials, new plumbing joint reinforcements, new electrical circuit designs. Hundreds of tests had been run to assure safety. For example, in a boilerplate command module, material and design changes in a portion of the right-hand equipment bay were tested in a simulated electrical fire. In this instance, circuit clamps had been redesigned primarily by reducing the amount of silicone rubber cushioning material, and protective panels had been incorporated. The fire was initiated by applying a hot nichrome wire igniter to a clamp's silicone rubber material. The environment was pure oxygen under 3 times the normal operating pressure of the spacecraft. There were 2 major questions. Would the fire propagate? Would electrical continuity be maintained? The answers were these. The fire remained localized, burning out in moments, having spread neither to the spacecraft cabin interior nor to a second clamp only 3/4 of an inch removed. Further, electrical continuity was maintained, and the mission would not have been jeopardized. In addition to hardware modifications, new operational procedures, for instance, better means of accounting for tools, had been initiated, with every effort directed at assuring hardware reliability and safety. As checkouts proceeded for the command and service modules, flight personnel were heavily involved in training and flight equipment evaluations and checkouts. The objective for the mission, now scheduled for launch in 1968, is simply this: to prove that the Apollo-operated Saturn I vehicle and flight equipment are capable of fulfilling requirements in manned spaceflight. The prime crew will be astronauts Walter Schirra, Walter Cunningham, and Don Isley. In anticipation of forthcoming manned missions primarily aimed at detailed investigations in space, a new group of 11 scientists was added to the corps of astronauts. These men bring to the program new skills in astronomy, physics, chemistry, physiology, medicine. Continuing to proceed concurrently with the development of our manned spaceflight capability were unmanned investigations of the moon. The Lunar Orbiter 5 mission, launched from Cape Kennedy on August 1st, brought a major phase of the unmanned investigations to a highly successful close. Circling the moon, Lunar Orbiter 5 returned pictures of all previously unphotographed sites, supplementary pictures on potential Apollo landing sites, plus pictures of 36 locations of major scientific interest. All 5 missions in the Lunar Orbiter program, directed by the Langley Research Center, met with success. Only a few weeks after the launching of Lunar Orbiter 5, Surveyor 5 was launched toward a successful soft landing on the moon in the Sea of Tranquility. Surveyor 5, under the direction of the Jet Propulsion Laboratory, returned photographs of features in the immediate vicinity, as well as new data on the nature of the lunar surface. Nothing yet has been indicated that would preclude manned landings on the moon. It is the work that has been done in Apollo and other programs, both manned and unmanned, that has opened the way to Apollo applications, the program to capitalize on our investments in manpower and money. A major piece of Apollo applications equipment is the orbital workshop, which is built by McDonnell Douglas. In September, a mock-up of the workshop was being prepared for disassembly so that it might be modified with all the latest design concepts incorporated. The workshop is basically a modified uprated Saturn I second stage. Fulfilling a dual role, it first propels itself into Earth orbit, then following the dumping or elimination of residue propellant and final preparations in space, it becomes a living and working quarters for a flight crew. Another major piece of Apollo applications equipment is the multiple docking adapter, which is built by the Marshall Spaceflight Center. At the end of September, a full-scale mock-up of the adapter was proceeding through assembly at Marshall. Launched with the orbital workshop, the adapter will provide 5 ports to receive subsequent payloads and will carry equipment and provide space for conducting certain scientific experiments. With the orbital workshop, the multiple docking adapter, and a variety of other equipment assembled in space, the result will be an Earth-orbiting manned scientific station. Such a station is indicative of the promise held by our steadily maturing manned spaceflight capability. With most of our Apollo development work completed at the end of September 1967, we were almost ready to initiate the series of missions, which will lead directly to the first manned mission to the moon.